Here is a matching type question on general organic chemistry. Study the items in both columns carefully. Try to work out the matching before we solve it together. Let us now begin solving this step by step. Benzylic hydrogens are hydrogens on sp3 carbon atoms that are directly attached to an aromatic, benzene, ring. Compound, a tricyclic structure, acenaphthene-like. The structure shown is acenaphthene, a benzene ring fused to a 5-membered ring and a 6-membered ring. Looking at the carbons adjacent to the benzene ring in the aliphatic portions, the 5-membered ring contributes to benzylic CH2 groups, each with 2H, and the 6-membered ring contributes to benzylic CH2 groups. Wait, let me re-examine. The structure appears to be fluorine-like or acenaphthene-like with 2 6-membered aliphatic rings fused to benzene. The benzene ring is fused to 2 cyclohexane rings. The carbons of the aliphatic rings directly bonded to benzene carbons are the benzylic positions. Each fusion point with the benzene ring gives benzylic carbons. For a benzene fused to 2 6-membered rings, like phenanthrene partial hydrogenation, there are benzylic CH2 groups. In this tricyclic system, acenaphthene analog with 2 6-membered rings, there are 4 benzylic CH2 carbons. Actually, for the structure shown, benzene plus 2 fused 6-membered rings, counting benzylic positions, the top 6-membered ring has 2 carbons bonded to benzene, both CH2, each with 2H is equal to 4H. The bottom 6-membered ring also has 2 carbons bonded to benzene, both CH2 is equal to 4H, but some are shared. Net benzylic H count is equal to 5. This matches S is equal to 5. Compound be indene with ethyl and 2 methyl groups. The indene core has a benzene fused to a 5-membered ring. Benzylic carbons are C1 and C3 of the 5-membered ring. C1 bears a CH3 substituent, so C1 has 1 benzylic H, C3 bears a CH3 substituent, so C3 has 1 benzylic H. The ethyl group, CH2CH3, on the benzene ring, the CH2 directly on benzene is benzylic with 2H. Total benzylic H is equal to 1 plus 1 plus 2 equals 4. This matches R is equal to 4. Compound C1-methyltetraline, 1-methyl 1, 2, 3, 4 tetrahydronaphthalene. Tetraline has benzylic carbons at C1 and C4, both directly attached to benzene. C1 has a methyl group, so C1 contributes 1 benzylic H, C4 is CH2, contributing to benzylic H, total is equal to 1 plus 2 equals 3. This matches Q is equal to 3. Compound D1, 4-dimethyltetraline, 1, 4-dimethyl 1, 2, 3, 4 tetrahydronaphthalene. C1 bears a methyl group, 1 benzylic H, C4 bears a methyl group, 1 benzylic H, total is equal to 1 plus 1 equals 2. This matches T is equal to 2. Summary. A. S5 benzylic hydrogens. B. R4 benzylic hydrogens. C. Q3 benzylic hydrogens. D. P2 benzylic hydrogens. Therefore, the correct answer is A. S, B, R, C, Q, D, P. Therefore, the correct matching is A matches S, B matches R, C matches Q, D matches P.